Hello students, welcome to the course Verilog HDL. In the previous uh, section, previous 4 videos, in the first section of this unit, we described the various gate types, that is AND OR gate types and buff NOT gate types. So totally we have seen 12 Verilog gate primitives. Okay, and we also modeled the some of the designs like 4:1 multiplexer and 4-bit triple carry full adder also we have seen. Okay, so with this knowledge you have understood so how to write your own Verilog program in the gate level description. Okay, so in the second part of this unit we'll be looking at the gate delays. Okay, so what is meant by rise, fall and turn off delays, and also in that minimum, max and typical delays. Okay, so gate delays until now. Okay, so in the multiplexer as well as 4-bit full adder, so we described the circuits without any delays, that is assumed it is zero delay. Okay, but in real circuits, in real time, logic gates have delays associated with them. Okay, so even the gates when they are making transition from 0 to 1, 1 to 0, okay, so it looks like fraction of second, but still they associated with a delay in nanoseconds or whatever. It is very important in real time circuit design. Okay, so that part we'll consider in this section. So gate delays allow the Verilog user to specify delays through the logic circuits. So even you can, as a user, you can give the delay for this program. Okay, after this much second you can execute this line of code. Okay, so like that we can give delay. So how to specify that delay in a gate level description, that part we see. And also pin to pin delays can also be specified in Verilog, but that we are not considering now. Maybe in advanced topics you may be considering this. Okay, so there are three types of delays from the inputs to the output of a primitive gate. Okay, so the three delays are rise delay, fall delay and turn off delay. Okay, we'll look at each one of them. So rise delay means it is associated with a gate output transition to a 1 from another value. So there are 4 values in Verilog HDL: 0, 1, xz. So now 0, xz. So these are the values we have. Okay, and this is the gate transition. Okay, so in general case we will draw like this straight, right? But it may not be straight, right? Okay, so it is having a delay here. Okay, so it is having a delay. So transition from 0, okay, or if you are in x state or if you are in z state and your output is transition to 1 now, okay, 1 state, so then there is a delay. So this is shown as a curve, right? And this time is called as the rise delay. Okay, so hope you have understood. So it is in general, ideally we will draw like this straight, right? But it is practically not so. Okay, so this is the idea. Similarly, we will see the fall delay, opposite of this. The fall delay is associated with a gate output transition to a 0 from another value. Okay, so 1, x or z, so it may be any value and it may transition to 0 level. Okay, so in ideal case we will draw like this, simply straight line, right? But it is not so, it is having a delay. Okay, so that delay is associated, is called as, so in general we have shown it as equal delay here. Okay, it may change, depends. Okay, so and it is denoted as t underscore fall. So it is the fall delay. So very simple, no much thing to explain here. So now turn off delay. Okay, so how we define turn off delay? The turn off delay is associated with a gate output transition to the high impedance value from another value. Okay, so diagram is not shown for this. Okay, so if you have any value, okay, 0, 1 and x, from this if you are going to high impedance state, okay, so we could not show this with a picture. Okay, where exactly z state will come. Okay, it is an state. Okay, high impedance state, it will come from any of this value to this. So that transition we call it as the turn off delay. Okay, if the value changes to x, the minimum of the 3 delays is considered. Okay, so that is what the idea about the 3 delays associated with the gates. Okay, so now we'll see the different types of delay specifications. Okay, so when you specify 1 delay, what is meant by that? 2 means what is meant by that? Okay, we'll see that. So this is called as delay specifications. So there are 3 types of delay specifications are allowed in Verilog. Okay, so if only one delay is specified, okay, if only one delay is specified in a gate transition, So this value is used for all the transitions. That means if you have considered in gate a delay of 1 unit, okay, so your delay of 1 unit, so this 1 unit will be considered for all the three, that is rise delay, fall delay, and turn off delay. Okay, we'll show this within a syntax and examples in the next slide. First we'll try to explain this. Okay, then if two delays are specified, they refer to the rise and fall delays. For example, if you specify like 1 comma 2 like this, okay, then one will be for rise delay, two for fall delay, and the minimum of these two will be as the turn off delays. Okay, so turn off delay is the minimum of the two delays. So that is how you need to consider. Okay, if all the three delays are specified, they refer to rise, fall, and turn off delay values. Okay, so if you write 1 comma sorry 1 comma 2 comma 3, so then 1 for rise delay, 2 for fall delay, 3 for turn off delay, like that it is understanding. Okay, if no delays are specified, the default value is 0. That is what we have seen in the first part of this gate level modeling. Okay, we have not specified delay at all. Okay, so then it is means 0. Okay, so no delay in the circuit. So we will see the syntax of this, how we mention, represent that, and how we give the example. Examples of delay specification are shown in example below. Okay, so delay of delay time for all transition I mentioned, right? So I am using a AND gate here. So this is a syntax, and this is the symbol we are using for delay. Okay, hash symbol we are using for delay. Remember this, and this is the delay time. Okay, in general we have written delay time. It may be any value, 1 to any decimal numbers you're writing accordingly. Then this is the instance name. Okay, so before the instance name, this delay part should come. Okay, and then remaining part as it is where we have looked in the first part. Okay, so it is delay of 1. If rise and fall delay specification, two delays are specified, so it will be like this. Okay, so number rise value will be written first, then a comma operator is used, and then fall value is written. Remaining part is same, instance name and remaining. Okay, so similarly 3 if you have to use. So I have used buff if 0 here. Any gate it can use. So we are writing rise value, comma fall value, comma turn off value. Okay, so instance name out in control. So this is the syntax. Now next slide we will see the example for this. Okay, so then you will understand clearly what is meant by this. Okay, so here 5 delay time is 5 we have used, meaning what, delay of 5 will be used for rise delay, fall delay, as well as turn off delay. Okay, so then 4 comma 6 we have written, meaning rise delay is 4, fall delay is 6, the minimum of 2 is how much, 4, right? That will be considered for turn off delay. That is I am not mentioned here. Okay, then buff if 0, 3 4 5 it is written, meaning what, 3 for rise, fall delay is 4, and turn off delay 5. Okay, another observation you need to look here is, so in the Verilog, so gate delay will be specified in terms of one time unit. Okay, here for example 5 is written, means it is 5 time units. Okay, and the meaning of this time unit, one time unit is equal to how much, it will be mentioned in the Verilog compiler. So whoever is providing you the circuit, so there it will be one time unit is equal to 1 nanosecond, okay, or 1 millisecond. Okay, it will be written. So accordingly compiler will understand that 5 means 5 nanosecond or 5 millisecond something. Okay, but in Verilog we don't have the keywords to use like nanosecond and all. Okay, but in VHDL, another type of programming, we have the millisecond. Okay, you can mention like this ms, ns, you can write along with the numbers. Okay, so that is different. Okay, so you don't confuse now. So in delay specification, just we are mentioning the number, it is called as 5 time units. So one time unit equal to how much, it depends on the technology. Okay, presently nano electronics are going on, chips are manufactured at the nano level, right, or micro level, depends. Okay, accordingly that will change as you update the your hardware as well as the software. Okay, fine. So this is about the first part of the uh, gate delays. Okay, that is about mentioning rise delay, fall delay, and turn off delay. So now again in this there are three classifications we have. So the values of minimum, maximum, and typical values, about that we'll look at. Verilog provides an additional level of control for each type of delay mentioned above. Okay, so for each type of delay, okay, rise, fall, and turn off, there are three values will be there. Minimum, typical, and maximum can be specified. That means what? So if you have a rise delay, so rise delay, you can specify the minimum value, maximum value, and the typical value. Typical value will be normally the average of these two. Similarly, for fall also you can mention minimum, typical, and max. Similarly, for turn off delay we can minimize. Okay, so how to differentiate that? We will use a colon operator here. Okay, so just to show you, earlier it was 1 comma 2 we have written, right? Rise, fall, like that. So now we will mention it like this: 1 is to 2 is to 3 is to 3 comma, okay, 4 is to 5 is to 6, okay, like that. Meaning what here? So this is completely rise delay, this is completely fall delay. In this rise delay, so this is the minimum value, maximum value, typical value. Okay, so like that. So any one value can be chosen at the start of the simulation. Okay, so minimum, typical, and max values are used to model devices whose delays vary within a minimum and maximum range of because of the IC fabrication process variations. So this is at the very minute level. So you are going digging deep into the digital circuit design. So even each nanosecond delay is very important for you, right? So where we are using precision like aeroplanes or in space vehicles, okay, satellites, okay, we are minute with each second of delay there. Okay, so that's why, sorry, that's why we need to consider that into case, then we will use this minimum, typical, and max values. Okay, so just we'll see the example how we use this. Okay, first we'll define this. Minimum value means is the minimum delay value that the designer expects the gate to have. Okay, when he has designed a gate, so how much minimum it can require. Okay, similarly, maximum value, okay, is the maximum delay value that the designer expects the gate to have. So in between that, the typical value places, so is the typical delay value that the designer expects the gate to have. Typical, that means on an average we will say, no, like that. So next, so based on this, minimum, typical, or maximum values can be chosen at Verilog runtime. Okay, so Verilog runtime, they will be chosen how much you can give. Method of choosing a minimum, typical, max value may vary for different simulators or operating systems. Okay, so these values we can give it in the beginning also as well as in the runtime. Like in dynamic allocation, you are doing in C programs, right? Malloc and all, you are using some functions, right? The same way here, we have some keywords to change that values in the during runtime. Okay, and that will change for different simulators. Okay, so Xilinx will provide simulators, Synopsys will provide simulators, like that. Many vendors or players are in the market, so according to that it will change. Okay, we here we will give it for Verilog simulator. Okay, so Verilog was invented from this simulator, right? Verilog Excel. So for that, how we will do that, we will show. The values are chosen by specifying options. So this is the keyword. Just you will mention plus max delays. Okay, this is the keyword. For typical value, you have to enter plus this value, then plus minimum delays. Okay, at the runtime, if you give these commands, so that will change the value. If no option is specified, the typical delay value is the default. Okay, so if maximum, minimum, nothing is mentioned, so typical delay will be taken into consideration. So this allows the designers the flexibility of building three delay values for each transition into their design. Okay, so rise, fall, and turn off delay, it's minimum, so it will give the flexibility. Okay, the designer can experiment with the delay values without modifying the design. So you already designed and you have written the program, so that you no need to change. So just you can play with the gate delay, so that, so gate delay is associated inversely with speed, right? So what you are looking in today's gadgets or mobile phone, so you will be looking at performance, right? Speed, so how fast it will open the apps and all, right? So this is very important, right? So their delay is the issue. Okay, so on that part they will be working. Okay, so similarly others also there, but speed or performance is one of the criteria in any electronic circuits. Okay, So example, how we write this minimum, typical and max values for Verilog simulator. Okay, so and 456. Okay, so minimum, sorry, so this is the only one delay is mentioned, meaning what? It is a rise delay. Minimum is 4, 5 is typical, 6 is maximum. Okay, only one delay is mentioned means it is a rise delay. Okay, it is used for all the transition, rise, fall and turn off. Okay, so just to mention, it is in simulator. So minimum delays, okay, delay equal to 4, typical delays delay equal to 5, max delays delay equal to 6. Okay. So this is one example. Similarly, we'll use it for so this is one delay, okay, for all transitions. Similar way, we will see the other two options also. Two delays. Okay, so if you have two delays, so how we use it? So and see here, 3 is to 4 is to 5. So along with hash symbol here, now this colon is another operator place, okay, for mentioning these delays. Okay, 3, 4, 5, this is the rise delay, and 5, 6, 7, it is the fall delay. Okay, so in this rise delay, 3 is the minimum, 4 is the typical, 5 is the maximum. Fall delay, 5 is the minimum, 7 is the max, 6 is the typical. Okay, so that is what mentioned here. Okay, minimum delays, typical delays and max delays. So for rise it is 3, fall it is 5, and turn off it is minimum of 3 comma 5. Okay, so here 3 is there, here 5 is there, so minimum of that is 3, it will be assigned to turn off. Similarly, the middle one, for typical delays, rise delay is 4, fall turn off delay is 6, so turn off delay will be 4 comma 6. So minimum max value, so turn off value minimum of that. Okay. Similarly, maximum delays, for rise time it is shown, okay, 5, fall time it is 7. Okay, turn off it should be minimum of those two in the case of two delays. Okay, hope you have understanding. Then if three delays are mentioned, straight away we'll use it. Okay, ash, this rise delay, fall delay, and this is the turn off delay. Okay, all the three are mentioned. So accordingly here, rise value, minimum delays, rise case it is 2, fall case it is 3, turn off case it is 4. That is the first value. Okay, and similarly typical delays, it is middle value 3, 4 and 5, and the max delays it is 4, 5 and 6. Okay, so this is what about the delays. Okay, rise, fall, turn off, as well as it's specifying minimum, typical and maximum values. Okay, so next we'll see how we do the runtime. Okay, so with respect to Verilog simulator, what is the command, okay, to change this value? So examples of invoking the Verilog Excel simulator with the command line options are shown below. Assume that the module with delays is declared in the file test.v. Okay, so all the delays whatever I have mentioned, so it is written in a file. So Verilog file test.v we have kept it. So just if you invoke now Verilog test.v plus max delays, so max delays will be inserted. So if you do plus mini delays, so minimum delays will be invoked. Invoke simulation with minimum delay. Similarly, invoke simulation with typical delay, test.v, typical delays. Okay. So this is about the gate delays in the circuit. Okay. So first part of the program we have not seen any delays. Okay. Normally in the sequential circuits like delay flip-flops, okay, D flip-flops, okay, and all there is a delay, right? Certain delay. So D flip-flop is what? So just whatever input is there, it will pass it to the output, but with a delay. That's why it is called as delay flip-flop or D flip-flop. Okay. So such examples we will consider in the next video. Okay. So just go through this video once again. So we discussed about the three types of delay and its three values. Okay. And also delay specifications also we have seen. One delay means what? Two delays specified means what? And all the three delays means what? Okay. So thank you. We'll see in the next video.